Hello students, today we're going to be looking at two very important formulas. We're going to see them show up throughout the entire year, so make sure you know what they are. The midpoint and the distance formula. Please don't forget to take notes as we go through the video and that you take the survey that follows. So the first thing I want you to do is think about the word midpoint. This can be broken down into two words. The first word I would look at would be mid. Mid implies somewhere in the middle. And then the second word here is point, and we talked about that in our last video, in our last set of classes. So if we put these two things together, midpoint, something in the middle, and it's a point, the definition should be obvious to you. It is a point that is in the middle. So a formal definition would be a point of midpoint is the point that divides a segment into two equal lengths. In other words, it's a point that's exactly in the middle, so that to the left and to the right of it is equal length. Our midpoint formula, again, this is based upon being on the coordinate plane, so I'm giving you coordinates, would be this. We add together the x's and divide by 2, and we add together the y's and divide by 2. You could think of it as the average of the x's and the average of the y's. If you remember learning mean, median, mode, and range, when we look at mean, we add all the ones that we have up and divide by how many. So if we have 1x here and 1x here, if we found the average of those or the mean of those, we add them, divide by 2. And then if we do the same thing with our y's, so we can add those two y's together and divide them by 2. Now keep in mind here that we don't do anything with those. We keep the x value separate as well as the y value separate. So we are actually finding this point right here, what its coordinate is. Another thing besides just the midpoint that cuts the line segment in half, they're all known as segment bisectors. Now as you can see here, we do have points, so technically yes, it is a midpoint, but it also could be a ray, a line, or a line segment. And the key thing here, or a plane. The key thing here is it's intersecting the segment at the midpoint. And what you'll find is we're going to be using markings to indicate that these two lengths here are the same. These are congruent marks. I call them tick marks. You can call them whatever you like. But this is indicating that the length from A to O, so this length here and this length here, are the exact same lengths. So whenever you see these tick marks, that's going to indicate congruence. The other formula we have is the distance formula. So before we were looking at the lengths of segments, and it's not always very straightforward. We went from something where we can take a ruler up against it or a number line up against it and calculate it easily to something that looks more like this on a coordinate plane. Now, while yes, technically we can use a ruler up against this to determine the length of it, we would have to kind of coordinate it with what the distance is as a point of 1 right here, what that length is there, and kind of correspond that to a ruler. And we can't just count this since it's on a diagonal. So you're not going to just count, oh, this is 1, 2, 3, 4. That's not how that's going to work. So we have ourselves a different formula that's going to help us out with that, and that's called the distance formula. So the distance formula can be used on maps and other grids in order to find the distance between 2 points. You'll find it, you can use it on maps like this, such as for taking a car trip. Yes, I realize that things might not be so straight, but if you want to find maybe how long it would take to take maybe a plane, that would be another option. The next one would be to targeting a rocket. So let's say you want to see how far away it is. You have to kind of angle or figure out what would the length be and then angle it so we hit that, as well as compute the distance a football is thrown. So these are just a couple of examples of being able to determine how far away things would be and how the distance formula is used. Okay, so let's actually go through and say what the distance formula is. So this is calculating the distance between 2 points, and we're generalizing it here with x1, y1, and x2, y2. And if we look at our diagram here, what we're going to do is actually form a right triangle in order to calculate this. And we discussed how to find the distance is through subtracting two things and taking the absolute value. And that's where this idea of subtracting x's and subtracting y's are coming from, is find the distance between the x values and the distance between the y values. But the actual formula is this: d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And as you can see, the x2 minus x1 is representing this length here, and the y2 minus y1 is representing this length here of how far up or down we go. So each of these individual pieces here and here are just indicating the distances, the change in the x's and the change in our y's. It's not going to really matter which one we decide to be x1, y1, or x2, y2 because we're squaring everything. And whenever you square something, you always are going to make it positive. This looks like another formula that you may have used in the past. If you can come up with it, let me know tomorrow. If you have any questions, please make sure you write them down now and bring them to class or ask them in the survey. Don't forget to take the survey after you finish with the video.